Hello and welcome. This is Chapter 5, Section 5, Other Trig Identities, Part A. Here are our main objectives for today. So the first thing we're going to talk about is the double angle identities. That is, if we have 2 times sum theta, we can do the sine of 2 theta is equal to 2 times sine of theta cosine of theta. And cosine of 2 theta is going to be equal to all of these three. Usually I pick the one that's the easiest. In our case, this is actually very useful later because cosine squared plus sine squared is 1, but cosine squared minus sine squared is actually cosine of 2, double that theta value. And all these things, and this tangent of 2 theta will be this function or identity here. So let's do an example using these 3 different types of double angle identities. So the idea is if I have the cosine of x is 3 over the square root of 10, I can set up and find the angle here. So I'm going to create a triangle. We know that cosine of x is in the positive region and it's in quadrant 1, so we're going to draw just a generic right triangle here. We know that that's our angle x here, and the hypotenuse is square root of 10, and the adjacent is 3. Remember, that is adjacent over hypotenuse. We can figure out this side right here by the Pythagorean theorem, which this ends up being 1. Again, this squared is 10, this squared is 9, 10 minus 9 is 1, and the square root of 1 is in fact 1. So that's how I did it, Pythagorean theorem. That is something we've been doing all year long. Now all we have to do is find the sine of an angle that's twice as big. So we're going to find an angle that's 2x's. So we're going to figure out what that would be if I made a triangle like that, if I put another x on there. So how do I do that? Well, I just use the function right here, this half of it, to do that. So the sine of 2x in this case is equal to 2 times the sine of x, which if you think about the sine of x in this case is opposite over hypotenuse, so 1 over the square root of 10, and then the cosine is the adjacent over the hypotenuse, so we get that. Now, we just have to simplify this, so what we do is times 2 times 1 times 3, which is 6, and then the square root of times the 10 times the square root of 10 is 10. So we end up getting 6 over 10, and we can simplify that as to be 3 over 5. So again, multiply the numerators, multiply the denominators, and simplify. And that's it. So now the cosine one, I just picked the first one. You could have picked any of them. It doesn't matter. We already figured out the sine of x and cosine of x, so we're just going to use those again here and then square them. So in this case, using what we did from before, the cosine we said was 3 square root of 10, because that was this one over here, and we're squaring it, subtracting by the sine, which is 1 over the square root of 10, and we're squaring that. So when we square this, remember it goes to the numerator and the denominator. So what happens is this is 3 to the second power, which is 9. And 10 squared, the square root of 10 squared is in fact just 10. And then 1 squared on top is 1, and the square root of 10 squared is that. So we end up getting 8 over 10, or 4/5. Now, in theory, we could figure out the tangent really easily because we know both the, so this is going to be cosine, this will be adjacent, and this will be our opposite. So tangent is opposite over adjacent, so it should be 3 over 4. If you remember, this is our adjacent value and our opposite value, so I should get 3/4 if I use this tangent of 2x, but we're going to apply that in this just to make sure that it is in fact 3 over 4, but that is a simple or faster way you could do it if you wanted to. But this is 2 times the tangent of x. The tangent of x, remember, is opposite over adjacent, so 1 over 3 in this case, so opposite adjacent 1 over 3. And then we're going to put it all over 1 minus that 1/3 all squared, which if you simplify that, that is 2/3 on top, and on the bottom it's 1 minus 1/9, which is 8 over 9. You can change flip. So when we do that, we get 2 over 3 times 9 over 8. And then we'll simplify that, which the 9 and the 3, if we look at here, this turns into 3 on the top, and this turns to 4 on the bottom, which is, in fact, 3/4. And we did, in fact, confirm that it was 3/4. But you could have used the triangle that you set up, because we know hypotenuse is 5, adjacent and opposite, and then just do tangent of that same angle, because that was with that 2x. So let's look at an example 2. We're going to simplify the expression by using a double angle formula. Notice that this is sine of 2 theta, cosine of 2 theta times 2. So it mimics that formula here. So remember, it's 2 sine of x, cosine of x. In this case, our x, just notice that x happens to be equal to 2 theta. That is the biggest part here, is notice that x is 2 theta. Because once you do that, we can say that this is going to be simply, so the sine of your 2 times, well, our x value is 2 theta, which ends up being the sine of 4 theta. So this is my answer right here, is just the sine of 4 theta if I go backwards and simplify it. Again, is just noticing what is actually the angle. Angle x is equal to 2 theta, and then plug it back in here well, we're going backwards and plugging it into this side versus plugging it into this side, so backwards. So please try this one on your own, see if you get an answer. I will have an answer shortly. So hopefully you tried these and got these answers. I just did the simple way of, remember, that is opposite, and this is going to be your adjacent. So we would get 120 over 119. One thing that you should note is that these are all positive. And that means when I doubled this entire angle, it ended up being, or pushing it back in this first quadrant. So when we actually double the angle, we don't exactly know what quadrant will be if we don't know exactly what the angle is. But we do know is if we keep the -5, the -12, because this is, if you think about the terminal point here, it'd be x is -12, y is -5. And we keep all of the negatives correctly, and we find that they're all positive, it should be in quadrant 1. Now, if you find that tangent was positive, it would still have remained in this quadrant. If you found that the cosine was positive, then it would have been in this quadrant, or sine is positive, it would have been in this quadrant, assuming that the other ones were negative. So just things to note, and something that you could definitely figure out knowing the positive or negative signs of this. Because remember, we know that this is cosine, all sine or tangent are positive in those quadrants. So these are half angle identities. And a lot of times we're looking for angles on the unit circle that we can't find that are exactly on the unit circle, but we know that if we cut them in half, we could find that angle. So these are called the half angle ones, and I'll show you how to use it. Notice how there's multiple different ones for tangent, and then there's sine and cosine. So, and then you have to basically, using the CAST, pick either positive or negative for the values. So in this problem, we're using tangents. So we just have to choose any of the tangent ones. There's 3 of them, so I'm just going to choose this one. It was kind of random. I just picked it. I didn't have a strategy. I just picked one of them. And then what we're going to do is we're going to find the tangent of 157 degrees. Now what I want to do is I want to times this by 2, and notice that that is 315 degrees. So that is actually what my theta will be equal to. So if I do this, I'm going to say that the tangent of 157.5 degrees is actually just the tangent. That's an equal sign. Sorry, let me erase that. That's an equal sign. So to the tangent of, well, if I do the 315 degrees divided by 2. So again, this will reference my theta in this formula over here. So now, just to do that, I'm going to do 1 minus cosine over sine, and we know how to do that for 315 degrees on that unit circle. So let's just substitute that in. So we're going to do 1 minus the cosine of 315 degrees over the sine of 315 degrees. Now, on the unit circle, that is in that bottom left quadrant, where it will be a positive square root of 2 over 2 and negative square root of 2 over 2 for my x and y values. So all I have to do is, well, cosine is that x value, so 1 minus the square root of 2 over 2, and then the sine is the negative square root of 2 over 2. Now, this doesn't look very appealing, but what we can do is simplify it. I'm not sure if your online homework would let you do that as an answer, but what we can do is when we're dividing by a fraction, just keep change flip. So I'm going to move this up and give me some space. So I'm going to rewrite this as 1 minus the square root of 2 over 2 times 2 negative 2 over that square root of 2. I'm just putting the negative with one of them. And then remember, this will end up multiplying to here and to here. So if I rewrite that, distributing it, I get negative 2 over square root of 2, and then it turns out to be a positive and 1. Because the 2's will cancel, the square root of 2's will cancel, so that's just 1, and the negatives turn into positive. And then you just have to rationalize this. So if you remember that, multiply by square root of 2 over 2 to both the top and the bottom. Therefore, we end up getting 1 and then minus the square root of 2 as a final answer. And I would just rather write it that way. So I just flipped and put the 1 in front, but this is going to become a negative 2 square root of 2 over 2. 2's cancel, so it's just negative square root of 2, which is why it's there. So let's do another one. We're doing sine, so I wrote down the sine half-angle identity. And remember that we can rewrite this as a degree. I always just put it in degrees because it makes it a lot easier. This ends up being 67.5 degrees. Remember, 3 times 180 divided by 8. And then if we think about it, we could rewrite this. If I double that 67.5, I get 135 degrees, but then we just say it's divided by 2. So that is what I'm actually going to do. And now we're going to think about theta is 135 degrees. So when we do this, we're going to be looking in where the quadrant is. So we're finding the sine of this angle here. So notice how that will be in quadrant 1, so that all are positive. So when we do this formula, we're going to have the positive and not the negative. So we know we're in quadrant 1 for a sine of 67.5. So we're using positive 1 here. So if it was by chance in like the bottom quadrant 3 or 4, you would pick the negative 1. So now let's do this. So let's plug in our values. So we have the positive square root of 1 minus cosine of this theta, which again, we are doing the sine, let me rewrite this, sine of theta, which is 135 over 2. Again, this is our theta value, so we're going to put this 135 right here. And then divide it all by 2. So now, when you simplify that, we have the square root of 1 minus that cosine of 135, which, if you remember, is in this quadrant up here, which gives us a negative square root of 2 over 2. So we have negative square root of 2 over 2. And then it's still all over 2. Okay, now we're going to have to simplify that. First off, this turns into a positive. And then what we can do is we can just multiply both this part by 2 and this part by 2, so that when we do this, we get 2, and then plus that square root of 2, all over 4, and that's all still under the square root here. And then, again, how did I do that? This 2 goes here to 2. This turns into plus, and then the 2 cancels out with that, so you're left with that square root of 2. And this 2 just multiplies to that. And now it's the square root of this top part and the square root of 4. We can split it apart as our final thing as the square root of 2 plus the square root of 2 all over 2. And that is what I would want as an answer. It's kind of like a square root inside of a square root here, which is kind of interesting. So please check this last one on your own. I'll have an answer shortly. So hopefully you tried it. The only real difference is there's going to be a negative still inside and a negative outside. Of that, just remember that this angle of 112.5 or this 5 pi over 12 will be in the quadrant 2 where only sine is positive, therefore cosine should be a negative value up in the top left quadrant, therefore the value is negative. And then it'll be basically the same process following through what we did on the other one.